Alright, so we've got mid-segments of triangles and trapezoids. So a mid-segment is what it sounds like, well, at least what it sounds like to me. So say you got a triangle, a mid-segment is halfway up each side. So that means that these guys are congruent and these guys are congruent. So it's connecting what's called midpoints. We've talked about midpoints before. It's connecting the midpoints of the two sides. Now, some fun facts about the mid-segment of a triangle. Mid-segments of a triangle, the mid-segment is parallel to the base, and it's also half the length. So if this was, say, 5 feet, this would be 10 feet. Okay? So mid-segments are parallel, or the mid-segment is parallel to the base, and it's half the length of the base. Cool. Trapezoids. Mid-segments of a trapezoid. Well, kind of the same deal here. If I draw a trapezoid, it can be isosceles. It doesn't have to be isosceles. If I connect the midpoints of the two sides, then that is our mid-segment of the trapezoid. So same stuff follows here and here. Boom. It is parallel to the base. These guys are congruent. These guys are congruent. But this is not half the length of the base. It's the average, so to speak, of my upper and lower base. So all three of those are parallel, in fact. Okay? And then, let's say for fun, that this is 6 feet. And let's say that the base down here is, how about 14 feet? Well, what's the middle length going to be? If I add those two up, 6 plus 14, and divide that by 2, 20 divided by 2, 10 feet. There we go. So, again, a little recap. The mid-segment is parallel to the base of the triangle, or in the case of the trapezoid, it's parallel to the bases. And then the triangle, it's half the length of the base. And in a trapezoid, it's half of the sum of the two bases, so to speak. It's right in the middle, right? It's the average of the two bases. Alright, so we got MC Hammer decided to once again pick up his hammer for one last construction project. He's framing a gable roof like the one pictured below. The building is 20 feet wide, length of the top plate, the way it's labeled down there. The roof is a 6/12 pitch, and the cross brace is halfway up the king post and rafters. Find the lengths of each board and the angles for the cuts. Alright, first off, let me fix this little bit of typo action here. Alright, what fancy math properties did you use? So, let's start with labeling our length of that top plate, which we have right here. That is 20 feet. Okay. So my halves would be like 10 and 10 here. That might come in handy. I'll just jot that down. Now, it says that cross brace is halfway up. Well, if it's halfway up, that means it's, to the midpoint here, to the midpoint here, to the midpoint here. That's a mid-segment of the triangle. And I know that my cross brace is then half the length of that top plate because it's halfway up. Right? It's a mid-segment, so it's 10 feet. Awesome. So I got my cross brace already. I do need to figure out the rafter lengths, and I also need to figure out the king post. This is going to have to go back into some older concepts. Okay? So what I have basically is a right triangle. So I'm cutting this whole thing, like just taking the left half of it. If this is 10, right, and it's a 6/12 pitch, I can figure out what my king post is, right? Well, if its rise over run is 6/12, and my rise is x and my run is 10, little cross multiplication is going to do the trick here after I set up that proportion. 6 times 10 is 60, equals 12 times x. If I divide by 12, what do I get for x? 5. Awesome. So my king post is equal to 5 feet. Awesome. All right, so I got my cross brace. I've got my king post. I just need to figure out my rafter. Well, it looks like if I, let's label that Y, that's my rafter there. I've already got that this is 5 now. What have we done in the past to figure out that hypotenuse? A little bit of a Pythagorean theorem, perhaps. 5 squared plus 10 squared equals Y squared. Woo! All right, so 5 squared is 25 plus 10 squared is 100. So 25 plus 100, that's 125, is equal to my Y squared. If I square root both sides, I get Y equals, well, the square root of 125 is approximately, so let's make those squiggly equals, 11.18, so we'll call it 11.2 for my length. Excellent. All right, so I've got the length of my rafters, 11.2 feet. I got my king post is 5 feet. I've got my top plate was given to me as 20 feet. My cross brace I know is half that, 10, because it is the mid segment. Since it's halfway up, it's at the midpoint of it, right? I do need to figure out some angles though. So what would my angle be down here? Oops. Why don't I change colors to let's go with red. What would my angle be right here? And then the other one would be up here. Okay. Well, I can do a little bit of inverse trig to figure that out. Oh my goodness, I just ruined everything. That was a terrible idea. Put that back. Okay. Why don't I try to group them? Yay! All right. So I got to find those two angles. It is a 6/12 pitch, so that'll get me the angle that it makes with the top plate. All right. So that'll give me my first angle, which is that one right there. Okay. Well, if my pitch is 5/12, and why don't I just draw this triangle out again so we can work with it. If it's a 6/12 pitch, that means that this would be 6 and this would be 12, my rise over my run. And I'm looking for this angle here, so 6 is my opposite and 12 is my adjacent. And much like I said back in the trig unit, the one we use the most is indeed tangent. So I'd take my tangent inverse, since I'm trying to find an angle, of 6 over 12. And that is approximately 26.56 or 565. Okay, so let's call it about 27 degrees. We'll round to the nearest degree for this one like we did before. Okay, well, that's that angle. What's the angle up at the top? Well, it'd be the complement of it, right? It'd be the complement of it because, one, it's part of a triangle, and we already got 90 degrees. So to add up to 180 it would just be the other portion of that, right? Or you could think of it as they're complements of each other, because a lot of our cuts that we're dealing with are perpendicular to one another. So if I want to find my complement of that, I would subtract that from 90, and the other angle would be 63 degrees. So those are my two angles that I'm dealing with when I'm cutting for the fascia, for up at the where we'll meet the ridge, for my bird's mouth cut, for where it meets the wall. All those parts come into play here with those angles. So just to recap here, as the only new piece of information on this one was applying the mid-segment of a triangle, which was to find our cross brace at 10 feet. Everything else that we just did here was pretty much review from previous units. All right, so we got Will Ferrell and John C. Reilly need even more room for activities in addition to the bunk beds and bay window they made. They are building a shed, which is pictured below. They need to figure out the width of the shed before they start using power tools. It's not labeled on there. But they do know that the collar tie, which is halfway up, is 5 feet long. Okay? So that collar tie, this guy right here, is 5 feet long, and it's halfway up the rafters. Okay, so how wide is that shed going to be? Well, if we apply what we know about mid-segments, then that width right there is going to be double. So 10 feet wide. Awesome. What would that mean about this down here? Also 10 feet. And if you see over here on the left, the height of the shed, this is 8 feet. So what's this guy right here? Also 8 feet. It's a rectangle, right? You're not going to build a weird shed that's not a rectangle, right? So applying those properties of rectangles, our quadrilaterals are super duper helpful. And also we got our awesome collar tie action there with our mid segment of a triangle. Okay. Now, I have a crazy question for you. Not that we would necessarily do this in construction, but let me just draw the roof real quick. We've got this 5-footer here, right? We know this guy's 10. What would, if I were to put another collar tie, not that I would, halfway between those, what would the length of that blue guy be right there? If that's halfway between these 2 points and halfway between these 2 points right there. Well, essentially what I have right now is an isosceles trapezoid. And what do I know about the mid-segment of that trapezoid as compared to the other two bases? Well, if I take that 5, add to that 10, and I divide that by 2, that's 15 divided by 2. That'll give me my length of that other board that I could put there, which I wouldn't necessarily, but just saying, a little bit of math never hurt anybody, you know? It's extra fun. All right. That was exciting.